Okay, in this section we're going to be looking at quadratic equations. And out of that section we're going to be solving quadratic equations by using 4 different methods. One is by factoring, the other one is by using the square root property, the other one is by by completing the square and by using the quadratic formula. And then also we're going to be looking at how to use a discriminant to determine the number and the type of solutions that we will have. Let's first define what a quadratic function is. A quadratic function is going to be any function of the form f of x is equal to ax squared plus bx plus c. In this case, a, b, and c are going to be real numbers, and of course a cannot be equal to 0. Because if a was equal to 0, then you would not have a quadratic function, you would have a linear function. Also, any quadratic function is going to be called a second degree function because the highest exponent that we're looking at here is going to be a 2. So that's why it's called a second degree function. And a quadratic equation in x is an equation that can be written in the general form of ax squared plus bx plus c. And in this case, a, b, and c are real numbers. A is not equal to 0. And of course, a second degree polynomial equation is another name for a quadratic equation because the highest exponent here is 2. Let's look at how we can solve a quadratic equation. The first method is by using the method of factoring, and for that we'll have to use what they call the zero product principle. And what that means is this: if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. Meaning, if a times b is equal to 0, then a is equal to 0 or b is equal to 0. And here's the method for solving the quadratic equation by factoring. If necessary, do rewrite the equation in general form by moving all terms to one side and obtaining a 0 on the other side. Then number 2, you're going to factor completely. And then number 3, apply the zero product principle by setting each factor equal to 0. And then 4th, you'll solve the equations in step number 3. And then number 5, check the solutions in the original equation. So this is the procedure that you'll use to solve a quadratic equation using the method of factoring. And we're going to apply this to this particular problem here. In fact, we have a couple of problems that we're going to look at. In part A, parts A and B, you're going to solve by factoring. And in part A, we have the equation 3x squared minus 9x equal to 0. 3x squared minus 9x is equal to 0, and we're going to solve this by using the method of factoring. Okay, notice that a 0 is on one side of the equation, so we're okay with that. But we need to factor 3x squared minus 9x. We only have 2 terms, so we're going to have to find a common factor that's in 3x squared and 9x. Here we see 3x is the common factor because I see a 3 and 9 has a 3 in it, and each term has an x in it. So we'll use 3x as the common factor. And then we'll do 3x squared divided by 3x. That's going to give me x. Minus 9x divided by 3x will be 3. So this will be 3x times x minus 3 equals to 0. And then we're going to set each factor equal to 0 using the zero product principle. That means we have 3x equal to 0, or the second factor, x minus 3, equals to 0. So here I'm applying the zero product principle by setting each factor equal to 0. And for each equation, I'm going to have to solve for x. So for 3x equal to 0, if you simplify that, you're going to find out that x does equal to 0. And then for x minus 3 is equal to 0, if you add 3, you're going to have x is equal to positive 3. So my two solutions for this quadratic equation will be x is equal to 0 or x is equal to 3. Now, you can mentally do the check if you like to, because if you replace 0 in the original equation, you're going to get a 0 on the left-hand side anyway. Replace the x with 3, so 3 squared is 9 times this 3 in the front, that's 27. 9 times 3 is 27, so 27 minus 27 is 0. So these are the two solutions to this quadratic equation. All right, now part B is a little bit different. We got 2x squared plus x equals 1. 2x squared plus x equals 1. Now notice that there is not a 0 on this side of the equation, so what we're going to have to do here is move the 1 over to where the 2x squared plus x is by subtracting 1. And when we do that, you're going to have 2x squared plus x minus 1 equal to 0. If I move the 1 over to the left side, it's going to change to minus 1. Notice I have 3 terms. So I'm going to have to factor this into 2 binomials as simply as I can possibly can. Now for 2x squared, that will have to be broken up as 2x and x. Now for the minus 1, the only factors of minus 1 will be a plus 1 and a minus 1. That means the plus 1 will have to go here, and the minus 1 will have to go here. That way, when I do the outer and the inner, that sum does give me the middle term. In this case, 2x and a minus 1x will give me a plus 1x, or just plus x. So 2x squared plus x minus 1 factors into 2x minus 1 and x plus 1, and that's going to be equal to 0. Then I set each binomial factor equal to 0 and solve for x. This means 2x minus 1 equals 0, or x plus 1 equals 0. And each equation I'm going to solve for x. So for 2x minus 1 is equal to 0, if I add 1, I'm going to have 2x equals 1, and then divide by 2. That means x equals a half. And then for x plus 1 is equal to 0, if I subtract 1, I'm going to have x is equal to negative 1. So my two solutions here in this case will be 1/2 and negative 1. Those are my only two solutions for this particular quadratic equation. Okay, now, so we talked about one particular method of of solving a quadratic equation. Now let's look at another method, and that's the square root property. The square root property states this: if u, less lowercase u, is an algebraic expression and d is a non-zero real number, then u squared equals to d will have exactly two solutions. And that means this: if u squared is equal to d, then u is going to be equal to the square root of d, or u is equal to negative square root of d. And that can be abbreviated as this: u is equal to plus or minus square root of d. Okay, that's how we can abbreviate this, using the symbol plus or minus. Now we're going to look at some examples that deal with just this. In fact, we have 3 problems that deal with using the square root property. We'll start with part A. We got 3x squared minus 21 equal to 0. And we want to solve this using the square root property. 3x squared minus 21 equals to 0. And in this case here, we want to get the x squared by itself. So let's get rid of the minus 21 by adding 21 on both sides. So here we're going to have 3x squared is equal to 21. And we still want to get the x squared by itself. It's being multiplied by 3, so let's divide by 3. So that means we're going to have x squared is equal to 7. And then to get the x squared by itself, well, it's being squared, so that means, well, it's by itself, but we want to solve for x. X is being squared, so the opposite of squaring something will be simply taking the square root on both sides of this equation. So that means we're going to have an x here, and then that's going to equal to, now here we have to introduce plus or minus. Now, of course, 7 is not a perfect square because there's no whole number squared that's going to give us 7. So we leave that as the square root of 7. So the final answer there will be x is equal to plus or minus square root of 7. And also you can write this as the square root of 7 and negative square root of 7. Okay, now let's look at part B. In part B, you have 5x squared plus 45 equal to 0. 5x squared plus 45 equals to 0. I'm going to draw a line here so I can separate part A from part B. Okay. Now, just like in part A, we want to get the x squared by itself. So let's get rid of the 45 by subtracting 45 on both sides, which means you're going to have 5x squared is equal to negative 45. And then to get the x squared by itself, we're multiplying it by 5, so you want to divide both sides by 5. So now x squared is equal to negative 9. But we want to solve for x. X is being squared, so the opposite of squaring something will be simply taking the square root. So we're going to take the square root on both sides of this equation. And the square root of x squared is x. Then that's equal to, and here we have to introduce plus or minus. Now the square root of 9, well, the square root of 9 is 3. But if you remember, we have the negative sign in front of the 9, so that means we need to introduce this as I. Now, if you remember in one of the videos, we talked about complex numbers here, so anytime you have the negative sign underneath the radical, we have to bring that out as an I. So here, this will be plus or minus 3i. And sometimes that can be written as 3i and negative 3i. Okay, that's basically what that means. All right, part C is written differently from A and B. Here we got x plus 5 quantity squared equals 11. X plus 5 quantity squared equals to 11. And here we want to solve this particular quadratic equation. Now, the way we do this is this. We take the value of x, add 5 to it, and whatever that sum is, we square it. Now we're going to do the reverse. We're first going to do the opposite of squaring it and the opposite of adding 5 to find out what x is. We start off with the square. The opposite of squaring something will simply take the square root on both sides. Now, on the left side, the square root of x plus 5 quantity squared would simply be x plus 5. That's equal to, bring in plus or minus, the square root of 11, because we know 11 is not a perfect square. Now we can get the x by itself. We're adding 5, so that means the opposite of adding 5 would simply be subtracting 5 on both sides. Now, these are two totally different terms. The negative 5 and the square root of 11 are two totally different terms. We can't combine those. So the only way we can simplify this is just simply rewrite this as negative 5 plus or minus the square root of 11. And what that means is this. You have 5 plus the square root of 11, and the other answer is 5 minus the square root of 11. Okay. So this is how you will solve quadratic equations by using what they call the square root property. All right, another method of solving quadratic equations, here's the third method, and that's by completing the square. And what we do when we complete the square is this. If x squared plus bx is a binomial, then adding b over 2, and that quotient is squared, which is the square of half the coefficient of x, a perfect square trinomial will result. That is, you have x squared plus bx, and then plus, you take half the coefficient of x, and then you square it. When you factor it out, it's going to be this, x plus b over 2 quantity squared. Okay, so that concept of completing the square, we're going to look at how that's going to be done in a few problems, like this one right here. What term should be added to each binomial so that it becomes a perfect square trinomial? Here you're going to write and factor the trinomial. So here we got three different problems here. We got x squared plus 6x. That's going to be part A. Okay, so here we want to use that concept of completing the square because we want to know what terms should be added to each binomial so it will become a perfect square trinomial. All right, let's look at the coefficient of x, which is 6. To do that, you take 1/2 the coefficient of x, which is 6. So here, half of 6 will be 3. And then you're going to square the 3, which will be 9. Okay? When you complete the square, take half the coefficient of x, and then you square it. Half of 6 is going to be 3, and then 3 squared will be 9. That's the number you're going to add to the x squared plus 6x. So here, we're going to have this perfect square trinomial, x squared plus 6x plus 9, which can be factored into, we know we're going to have an x plus, now if you remember the b over 2, take half the coefficient of 6, which is, of course, 3. And that 3 will go right here. So that x squared plus 6x plus 9 will be factored into x plus 3 quantity squared. Okay. Another example will be x squared minus 5x. Okay. So we want to find out what terms should be added to each binomial so that we'll get a perfect square trinomial. Okay, so we look at the negative 5 here. We're going to take 1/2 of the coefficient of x, which is negative 5, and that's going to be a negative 5 over 2. And then square it. When we square negative 5 over 2, we square the numerator and the denominator. So negative 5 and u squared will be positive 25. Take the 2 and u squared, that's going to be 4. So we're going to have 25 over 4. So our perfect square trinomial will be x squared minus 5x, then plus 25 over 4, which can be factored into, of course, you know, you're going to have an x. Now, you take 1/2 the coefficient of x, which is negative 5, and use, which will give you negative 5 over 2. So we'll write that as minus 5 over 2. So it'll end up being x minus 5 over 2 quantity squared. Okay. And then part C, we got x squared plus 2/3 x. And we want to write this as a perfect square trinomial and then factor it. So we want to find out what term we're going to have to add to that. All right, the coefficient of x is 2/3. So here we take 1/2 of the coefficient of x, which is 2/3. So 1/2 of 2/3, let's do this. Cross canceling with these 2's, you're going to get 1/3. And then we're going to square the 1/3. So 1/3 squared is like 1/3 times 1/3, or 1/9. So the 1/9 is going to be the number that we're going to add to this particular binomial. So here, your perfect square trinomial will be x squared plus 2/3 x plus 1/9. And this can be factored into, we know we're going to have an x. Now we took 1/2 of 2/3, that gave us the 1/3. That 1/3 would go here as plus 1/3. So here, x squared plus 2/3 x plus 1/9 will factor into x plus 1/3 quantity squared. Okay. So that's how you use the concept of completing the square to come up with your perfect square trinomials, because you'll be applying that to quadratic equations where you have to use the perfect square. Okay, so here's some more information about completing the square. When you add a constant term to one side of the equation to complete the square, be certain to add the same constant on the other side of the equation. Just like when you solve equations, whatever you do on one side of the equation, you must do the same thing on the other side. That also applies when you're completing the square. Like in this particular example, let's say we want to solve this quadratic equation by completing the square. Here we got x squared plus 4x minus 1 equal to 0. X squared plus 4x minus 1 equal to 0. Now, here's how I'm going to start this particular problem off. The constant term, I'm going to move over to the opposite side. I'm going to add 1. And here I'm going to skip this step because pretty much if you add 1 to the opposite side, you're going to have a 1 here on the right side. I'm just moving the minus 1 over to the opposite side. It will change to 1. So here I'm going to have x squared plus 4x equal to 1. Because it's this left side that I want to work with so that I can use the concept of completing the square on this side. So let's talk about how we can complete the square here. Completing the square, the coefficient of x is 4. So we're going to take 1/2 of 4. That's going to give us 2. And then we want to square that 2. That's going to give you 4. 1/2 the coefficient of x is 1/2 of 4. That's going to give you 2. And then square it, which is going to give us 4. So that means we're going to add 4 to this side. And if I add 4 on the left-hand side of this equation, I need to add 4 on the right side of that equation as well. Okay? Now the left side of this equation is a perfect square trinomial that can be factored like this. We're going to have an x here. Now, we take half the coefficient of x, 1/2 of 4, that's going to be a plus 2. That goes here. So x squared plus 4x plus 4 will be x plus 2 quantity squared. And then that's equal to 1 plus 4. Of course, that's going to give you 5. So here I have the equation x plus 2 quantity squared equals to 5. Now what I need to do here is the one that I did in part C of that previous example before that. Well, when I was using the square root property, this is what we're going to use here. The opposite of squaring something will simply take the square root on both sides. And then x plus 2 quantity squared, and you take its square root, it'll be x plus 2. And that's equal to plus or minus the square root of 5. And of course, we know 5 is not a perfect square, so we leave it as is. Now we can get the x by itself. We're adding 2, so we need to subtract 2 on both sides. So that means x is equal to negative 2 plus or minus the square root of 5. And I believe we can leave it as is. Sometimes they may write this as negative 2 plus square root of 5, and then negative 2 minus the square root of 5. Okay? So that's how you'll solve a quadratic equation using the concept of completing the square. Okay. Now suppose the coefficient of your x squared term is not 1. If it's not a 1 for your x squared term, then that means you're going to have to divide each side of the equation by this coefficient before you complete the square. And I do think I have an example of something just like that. Let's say in this problem we want to find all the zeros of this particular function. F of x is equal to 2x squared plus 3x minus 4. F of x is equal to 2x squared plus 3x minus 4. You can see that the coefficient of your x squared term is not 1. So that means we're going to have to use something else. We're going to have to divide. Okay. Now the first thing we're going to do here is this. We're finding all the zeros, so that means we need to set this particular function equal to 0. So we'll set 2x squared plus 3x minus 4 equal to 0. We'll set that equal to 0. And what we're going to do here, since that 2 is in front of the x squared, we're going to divide each and every term in this equation by 2. Just like this. That means I'm going to have x squared plus 3 halves x minus 2 equal to 0. Now I'm going to do the next thing. I'm going to leave all the terms that have x's on the left side and move the constant over to the other side. So this minus 2 is going to go over to the other side. So I'm just going to have x squared plus 3 halves x equals to 2. Now I'm going to go ahead and complete the square. Okay. Now when we complete the square, we always take 1/2 the coefficient of x and then square it. So on the side, I'm going to say 1/2 of x, the coefficient of x has 3 halves. So 1/2 of 3 over 2 will simply be 3/4. And then we square the 3/4, which is 9 over 16. 3 squared is 9, 4 squared is 16. So I'm going to add 9 over 16 to this side of the equation, and I'm also going to add 9 over 16 to the other side of the equation. Remember, what you do on one side, you must do the same thing on the other side. Now, x squared plus 3 halves x plus 9 over 16 can be factored, is a perfect square trinomial. It can be factored as this. We know we're going to have an x, then plus, because the middle term is a plus. Take 1/2 of 3 over 2, that's going to give you the 3/4 that goes here. So we have x plus 3 over 4 quantity squared. That's going to be equal to, now this one's a little bit tricky. You got 2 plus 9 over 16. Now with your calculator you can do 2 plus 9 divided by 16 and then change it to a fraction, and it'll be 41 over 16. Okay. Now I won't take the time to go over it, but you know, if you have a TI 83 or 84 plus calculator, you can do like I did here, 2 plus 9 over 16. That gave me 2.5625. Then press the math key and select number 1 for the fraction, because you want to change that answer into a fraction, which will be 41 over 16, which is what I have here. Now, let's go ahead and take the square root on both sides using the square root property. And I'm going to have to continue this up here. The square root of x plus 3/4 quantity squared is just simply x plus 3/4. And that's equal to, bringing in plus or minus. We can't take the square root of 41, so we'll just leave that as is. Over the square root of 16 is going to be 4. So we get x plus 3/4 equals plus or minus the square root of 41 over 4. Now to get the x by itself, we'll subtract 3/4 on both sides, which means we're going to have x is equal to negative 3/4 plus or minus the square root of 41 over 4. Now in this case here, the denominators are the same. I can just write that whole thing over 4. So we have negative 3 plus or minus the square root of 41. The whole thing will be over 4. And that would be your final answer. One answer could be negative 3 plus square root of 41 over 4. The other one could be negative 3 minus the square root of 41 over 4. Okay. So this is how you will complete the square when dealing with quadratic equations. You know, with completing the square, you always take 1/2 the coefficient of x and square it to get the number that you're going to add to both sides of the equation. And this one, in this particular case, you have to make that coefficient of x squared a 1 by dividing by whatever that coefficient is in front of the x squared before you start the process of completing the square. Okay. Now, with that last example that I just did, this one is much easier to use. And that is the quadratic formula. If factoring does not work, then this option would work the best, and that's using the quadratic formula. The solutions of a quadratic equation in general form, ax squared plus bx plus c equal to 0, where a is not equal to 0, are given by using the quadratic formula. And in this case here, you have x squared equals to negative b plus or minus the square root of b squared minus 4ac, and that whole thing is divided by 2a. Okay. The equation has to be in general form. That means you have to have a 0 on one side of the equation before you can attempt to use the quadratic formula. And we're going to look at an example of how to solve using the quadratic formula. Let's say we have this equation, 2x squared plus 2x minus 1 equal to 0. 2x squared minus plus 2x minus 1 equal to 0. And we want to solve this using the quadratic formula. As you can see, we have a 0 on one side of the equation. So let's identify a, b, and c. A is the number that's in front of your x squared. That's 2. The b is the number in front of x. That's also 2. The c is your constant. That's negative 1. And I'll go ahead and rewrite the quadratic formula. That's x is equal to negative b plus or minus the square root of b squared minus 4ac. That whole thing is going to be divided by 2a. And then we're going to replace a, b, and c in this quadratic formula. The b is 2, so we got negative 2 plus or minus the square root of b squared. Again, b is 2, that's going to be 2 squared, minus 4 times a, which is 2, times c, which is negative 1. And all that's divided by 2 times, and a is 2, so that'll be 2 times 2. Now let's simplify all of this, especially the part that's underneath the radical. Bring down the negative 2 plus or minus the square root of 2 squared, that's going to be 4. Minus 4 times 2, that's a minus 8, times that minus 1 would be a plus 8. All that's over 2 times 2, that's going to give you 4. And underneath the radical, 4 plus 8 will be 12. So here we're going to have x is equal to negative 2 plus or minus the square root of 12 all over 4. Now notice that 12 does have a perfect square in it, and that's a 4. So 12 can be rewritten as 4 times 3. So we're going to have negative 2 plus or minus the square root of 4 times 3 divided by 4. Okay, because you want to find out if a number underneath the radical has a perfect square in it, because you want to take out that perfect square as well. So the square root of 4 right here, that's 2. So we're going to have negative 2 plus or minus 2 square root of 3. That whole thing is over 4. I'm almost finished because we can reduce this. Okay? Notice in the numerator, a 2 has a common factor in it. So let's pull out the 2. Then I'm going to do negative 2 divided by 2. That's going to be negative 1 plus or minus 2 square root of 3 divided by 2 is just simply square root of 3. That whole thing is over 4. Now this can be reduced. That 2 goes into this 4 2 times. So in the numerator, I'm going to have negative 1 plus or minus the square root of 3. That whole thing is over 2. And that's going to be my final answer right there. Now in this case here, it'll be 1 plus square root of 3 over 2 and 1 minus square root of 3 over 2. Okay. Let's look at another example of the quadratic formula. Let's say we want to solve this particular quadratic equation using the quadratic formula. Here we got x squared minus 2x plus 2 equal to 0. X squared plus 2x minus 2 equal to 0. Okay. X squared minus 2x plus 2 is equal to 0. Our a is the coefficient of x squared, that's a 1. The b is the coefficient of x, that's negative 2. And c is your constant, that's a positive 2. So a is 1, b is negative 2, c is 2. And our quadratic formula, of course, is this. X is equal to negative b plus or minus the square root of b squared minus 4ac. And all of that's divided by 2a. Now let's replace the a, the b, and the c in this quadratic formula to find out what our solutions are. Let's see. Negative b is negative 2, so we're going to have negative of a negative 2 plus or minus the square root of b again is negative 2, and that's squared, minus 4 times a, which is 1, times c, which is 2, divided by 2 times a, or 2 times 1. Okay, let's go ahead and clear up this fiasco that we have here. Negative of a negative 2 is 2, plus or minus the square root of negative 2 squared is negative 2 times negative 2. That's 4. Minus 4 times 1, which is 4, minus, well, 4 times 1 is 4 times 2 is 8. So we got underneath the radical 4 minus 8, divided by 2 times 1, which is 2. And then 4 minus 8, that's going to be negative 4 underneath this radical. So we got 2 plus or minus the square root of negative 4 all over 2. Well, the square root of negative 4 is 2i. Square root of 4 is 2. We got a negative sign there, so the I has to come out. So here's what we're going to have. 2 plus or minus 2i all over 2. Okay, now what we're going to do here is just simplify this as 2 over 2 plus or minus 2i over 2. Well, 2 divided by 2 is 1, plus or minus, and then these 2's divide out, you're left with I. So this will be 1 plus or minus I, which means 1 plus I or 1 minus I. Okay. All right, now, the last thing I want to talk about is the discriminant. Remember that b squared minus 4ac that was underneath the radical in your quadratic formula? That has a special name. It's called the discriminant. And what that does, it tells you the number and the type of solutions that you will have. And that's that quantity b squared minus 4ac. That's that expression that's underneath that radical in the quadratic formula. So here, in this case here, that's going to tell you the number and the type of solutions here. If your discriminant is positive, that means if it's greater than 0, that means you have two unequal real number solutions. If the discriminant is 0, that means you only have one real number solution. And if the discriminant is less than 0, or if it's negative, that means you only have two imaginary solutions, or no real solution. Okay. And we're going to look at a few problems that have, where we're going to apply the discriminant to find out what type of solutions we're going to have. All right, for each equation, you want to compute the discriminant and then determine the number and the type of solutions that you will have. All right, so if you look at part A, you're going to have you're going to have this equation, x squared plus 6x plus 9 equal to 0. Okay, so here we want to identify find out what the discriminant is and find out what the number and the type of solutions we're going to have. Well, we need to identify A, B, and C. A is the number that's in front of the x squared, that's going to be 1. The B is the number in front of the x, that's 6. And C is that constant, that's going to be 9. So the discriminant we're using is b squared minus 4ac, which means b is 6, so that means we're going to have 6 squared minus 4 times a, which is 1, times c, which is 9. And then if you simplify this, 6 squared, or 6 times 6, that's 36, minus 4 times 1 times 9, that's going to give you 36. So 36 minus 36 is 0. So here the discriminant is 0, which means that this particular quadratic equation is only going to have one real number solution. Only one real number solution for this one, because our discriminant is 0. All right, now look at part B. You have the equation 2x squared minus 7x minus 4 equal to 0. And you want to find out what the discriminant is for this one and the number of types, the type of solutions you're going to have. All right, let's find out what A is. That's the number in front of x squared, that's 2. B is the coefficient of x, that's -7. The c is the constant, that's -4. And then we're going to use that b squared minus 4ac. In this case, your b is -7, so this is -7, and that's squared, minus 4 times a, which is 2, times c, which is -4. Let's simplify this. -7 squared is -7 times -7, which is 49. Minus 4 times 2, that's a -8. Minus 8 times that -4 is going to be a plus 32. So now you got 49 plus 32, which will give you 81. So the discriminant is 81, and that discriminant is positive. That means it's bigger than 0. So that means the type of solutions you're going to have are going to be two unequal real solutions. Two unequal real solutions. Okay, and finally, part C, we got 3x squared minus 2x plus 4. And here we want to find the discriminant and then determine the number and the type of solutions you're going to have. In this case here, our A is 3, the B is -2, and C is 4. And I should put equal to 0 here, since it's a quadratic equation. And then we use the discriminant quantity b squared minus 4ac, or expression. The b is -2, so we're going to have -2 and it's squared, minus 4 times a, which is 3, times c, which is 4. -2 squared is -2 times -2, which will be 4, minus 4 times 3, which is 12, times 4, which will be 48. So now you have 4 minus 48. That's a -44. In this case, -44 is less than 0. It is negative, so that means the type of solutions that we will have for this quadratic equation, you will have no real solution. And if you have no real solution, that means you're going to have two imaginary solutions, because of the fact that the b squared minus 4ac is underneath the radical. So that means you'll have the square root of -44, which means an I will be involved in this particular problem. So that's why you will have two imaginary solutions. Okay, and that will conclude this discussion on the types of equations, or quadratic equations.